and hello, dear fellow panelists. Welcome to the last webinar of the 2023 Offshore Wind Task Force, part of the DRBF Insight Sustainability series of our Region 2. Today's topic, site preparations and surveys, avoiding unexpected costs, with Niklas Rigby, Sebastian Höök, and Tobias Vogt. I am Georgiana Tekuc, President-elect of the DRBF Board of Directors Region 2, and I'm your host for today. For those of you new to Dispute Resolution Board Foundation, DRBF was established back in 1996 by the creators of the dispute board process, with a mission to develop dispute avoidance and effective resolution for construction projects. Today, the association has over 1,400 members in over 70 countries. And as the dispute board process has expanded worldwide and now used on a wide variety of projects and long-term contracts of many types and sizes, DRBF develops best practices and offers training and educational resources for project owners, contractors, and DB practitioners. It also partners with other industry organizations to adapt the DB process to new sectors. It also may be of interest to you to know that DRBF is publishing a guide to best practices and procedures, the DB manual, now available in English, French, Spanish, and Portuguese. Back to our topic of today. Nick will walk us through some of the key challenges of building an offshore wind farm, in particular those related to site conditions. Sebastian will then show us how the parties and the dispute board can deal with those and how they can avoid unexpected costs, but also about the pros and cons of a standardized approach to this. And then Tobias will actually unveil for us what actually happens in reality. To introduce to you our speakers in the order they're going to talk, Niklas Rigby is a chartered engineer and fellow of the Energy Institute and has more than 35 years experience across the energy industry. He started NRG Management Consultancy to provide contract management and expert witness services to energy companies who find themselves involved in disputes. Nick has experience of dispute resolution across multiple jurisdictions and project types, and is a member of the FIDIC task group developing a standard offshore wind contract. His primary focus is on grid and offshore wind projects. And prior to starting Energy Management Consultancy, he was the head of the contract management at Low Carbon Contracts, and also a dispute director and head of strategy at RWE Energy. Sebastian Höök was admitted to the bar in Berlin, Germany, more than 30 years ago. He has accompanied complex engineering and construction projects worldwide in the areas of infrastructure, energy generation, mobility, and process engineering. Sebastian is a FIDIC-approved and listed dispute adjudicator and has been involved in major offshore projects during the last 10 years as a DAB member, but also as an expert. He's also a FIDIC accredited trainer and member of 2 FIDIC task groups and nominated chair for the FIDIC EPCM task group. Tobias Vogt was admitted to the bar in Germany more than 20 years ago. He also accompanied complex engineering and construction projects worldwide in the areas of infrastructure, energy generation, mobility, and process engineering. Tobias heads the Working Group on International Construction Law of the German Lawyers Association and is the chairman of the Offshore Dispute Resolution Committee of the World Forum Offshore Wind. And my co-moderator today is Gerard Monaghan, the DRBF country representative for Ireland. And if you bear with me for a second, Niklas, please get ready.
Well, good day, everybody. And I will just be giving a short introduction to the issues of site conditions and how to allocate the risk associated therewith. Show the first slide, please. So why are we so concerned about ground conditions, particularly for offshore wind? Well, the seabed in the locations where we build offshore wind farms, we have limited existing data for those locations, not like what we do have onshore. And the locations themselves are inaccessible. Could we go back, please? 2 slides. So locations are inaccessible. Some surface challenges are recorded, such as wrecks and other cables, but others are not recorded, such as unexploded ordnance, fishing shoals that are always moving around, and other things that are going on the seabed. Ground evaluation studies over the very large area that an offshore wind farm takes are costly and therefore need to be scheduled. Next slide. So if we think about the allocation of risk according to Abrahamson's principles, and if we think about the ability to control the risk associated with ground conditions, well, the employer has longer to evaluate. They are more familiar with the site. They have access to it for much longer than the contractor does. So they have a particularly good window of opportunity to carry out ground surveys. On the other hand, the contractor understands the data best and knows how to manage different and mitigate risks and changes that take place when ground conditions are not as expected. It's virtually impossible for either side to transfer the risk by insurance, so we can't push it down that hole. Let's now consider who is the beneficiary if the risk doesn't occur, it isn't accrued. Well, if the project is done at a lower cost, then that profit goes to the employer. So the employer benefits in some circumstances. On the other hand, if the contractor bids on the basis of him expecting bad ground conditions and they turn out not to be as bad, then the contractor will benefit because he will be able to do the job quicker and at less cost. In the interest of efficiency, it's not a good idea to move excessive risk or transfer it from one party to another. So we will need to consider that when we think about appropriate risk allocation. And in terms of who sees the loss in the first instance, potentially that will be the contractor. And so the employer only finds out about it when the contractor comes to him and says, we have a problem. So if we now move on to, let's say, one possible approach. Next slide. Well, it would seem logical that the employer should initiate ground surveys as soon as the structure and the cable locations are known. The extent of that survey should be subject to cost-benefit analysis because not every location, it's not feasible to look at every location. Now, the new element of this approach is to suggest that potential contractors, so this is contractors who are being approached by the employer and asked if they might be interested in bidding. But all these potential contractors can be asked to comment on the extent of the survey. The survey outcome obviously should be shared with all bidders. And the bid responses from the contractors should include feedback on the survey and any additional surveys that may be appropriate within the time available before work starts. And secondly, the bid response should include a schedule of costs for additional works if the ground conditions don't turn out to be as expected. So ultimately, it seems most appropriate that the employer takes unexpected ground conditions other than outside of the survey. And that's on the assumption that the contractor has engaged in the process of feedback on the surveys, etc. Now, it's not very practical to be able to sanction a non-engaging contractor, but as the request for engagement is during or before and during the bidding process, one would expect an employer to consider the extent to which the contractor has engaged as part of his consideration when he's selecting his preferred bidder, and if the preferred bidder becomes the actual contractor, again, we would need to be considering the contractor's response to questions and provision of information in relation to the ground surveys. Okay, well, thanks very much indeed. That's all I wanted to say. I'll hand over now to Sebastian to tell us more about pros and cons of standard approaches.
Okay, thank you very much, Nick, for your fabulous introduction into the subject matter and the insights we have heard. I just need to open up. Okay, I'm here. So yeah, thank you. We are now continuing to look at the pros and cons of the standardized approach regarding site surveys and site preparation. But of course, as we are within the DRBF, first of all, a bit of an introduction to our particularity, which is that we go on site and we touch, we hear, we listen, we smell, we see, we even may taste. And a lot of these particular skills, human skills, are very useful also in this particular field, rather than to sit somewhere and to just look at a file. I think that makes our difference. And nevertheless, of course, it is much important, as Nick has pointed out already, that we do know precisely the geological conditions and geotechnical characteristics of the subsurface at the actual sites of all components of an offshore wind farm, and therefore it is worth to look at details. Offshore construction involves more than just the knowledge about geotech as such and a particular topography at subsoil, because there is a lot of interaction. Scour protection, for instance, is something which you need to do, but it involves much more than to look at the soil itself. You need to look at stream, tide, and other stuff in order to be really aware of the full amount of problems, particularly also during construction, the execution of construction works. Because a part of what we are doing is definitely, of course, linked to the design. Another part is certainly that we do understand the particular working conditions. And my experience on offshore is basically that we very frequently have problems to face in terms of working conditions on your way to install something. Risk has Nick has already looked at the risk and Max Abrahamson's approach. We basically, of course, might have a full view only if we look at also differences. You see here that in terms of subsoil conditions, soil conditions, the Germans have basically a legal approach to say, well, it's an employer's problem. And the English will probably assume that that is a contractor's problem. Now, coming from both sides, you might have finally a common agreement, but within a jurisdiction, it might not be as easy. Though, of course, a standard like FIDIC might come to a conclusion which is very much in the middle of everything. So we will have to look at probability and the likelihood of risk to occur. And we may have to look at qualitative and quantitative approaches in order to better understand what can happen, but what also is relevant in this regard, because not always will always occur. So we have to look at the balance of everything sometimes in an individual way. Data sources are, of course, available in various places. We may have access to admiralty charge formation, geological surveys, geotech surveys, visual surveys, and other stuff. We will have to build the full picture, but of course not always we do have a full amount of information. Frequently it is just indicative, a snapshot, and you need to look at statistics. And already the warming of this wonderful Earth shows that these things are no longer really very much predictable, because you have changes everywhere. So we need to some extent to look at the allocation of risk and the approach to these type of information. You find various approaches, and you see here simply three: FIDIC, ENAA, and NEC. FIDIC, because it is probably in the wind sector the most prominent one. ENAA is a kind of competitor which comes from Japan, but has many friends, particularly also within the banks or the funding institutions, and then NEC as a new model from the United Kingdom. And you see here, to some extent, of course, commonalities, but also the dissimilarities. And you will have to look at those from time to time in terms of detail, but also in terms, of course, of impact. And frequently, these standards, and that is a cons, the standards do not really look at offshore. Right? If you look at FIDIC, ENAA, and NEC, there's not really much which you could really identify to be offshore relevant, though of course not everything is bad, because we look at hydrological climatic conditions in general, but probably this is not sufficient for particular projects like offshore projects in which we might become involved. So of course standards may help, but whatever standard you take, you might ask yourself first whether there is an assumption that this standard is applicable without further discussion to what we do in terms of offshore, or whether this requires amendments, adjustments, or further consideration. On the other hand, we do have not only, of course, contract standards, which basically may allocate risk and invite people to do things at the right time properly in collecting facts and allocating then the risk. But we have also these particular standards in terms of ground investigation. So this one is from the German, from a German authority, the Federal Maritime and Hydrographic Agency, in German briefly abbreviated BSH. And they have published a standard for ground investigation. But again, you will have to ask yourself the question, for which purpose? Because basically BSH is there to look at zoning and particular building regulations. They do not look at risk under a contract to be allocated to a contractor or to remain with an employer. So for them, the catalogue of things to be undertaken is not focusing basically on the risk during construction. They look at other risk regarding construction in the Northern Sea, the Baltic Sea, for instance, which is, of course, not always the appropriate approach for what we are doing. We do have, of course, also other standards, and here is one from the US. They have express terms learned also from European authorities, but there are, of course, also dissimilarities. There is a phased approach. You see a conceptual geological framework, relevant geotech parameters, geological risk registers to be established. And they take into account seabed mobility and other stuff, as you can see here. But again, I'm not sure whether this is always also sufficient to be a standard in the field in order to become aware of all elements which we need in order to understand the risk in full, which is involved in the business. So we do have typically survey observations, design observations, tender observations, contract award, and then resulting issues, because not always everything is done in accordance with the requirements, the actual requirements. It is frequently done with standards or standard approach, also in order to save money. So things are not done to cost, things are not done to time frequently. They're just looking at quality and or sustainability probably. So there's a lot to say about details. And then sometimes things will result in a commercial unbalance because of lacking data, which is of course then a reason for inflated claims and claimsmanship. And that brings again the DABs in place and to the attention of everybody, because we will have to deal finally with these disputes which arise out of. We do have also other tools, and I was supposed to talk a bit about standards. You see here a very interesting tool from the American Association of Cost Engineers on the classification of design for the purposes of estimating construction costs. But again, here we do have very little amount of impact in input in terms of working conditions. So also this type of standard may not always be a very, very reliable source for the estimation of costs which are involved in a project, which again, of course, is important for banks, investors, but also, of course, for contractors who must know whether their money is available for all type of variation and risk which may occur, which is classified to be employer's risk. So we will have to look at these particular standards, including, of course, the DIN 276 from a German perspective, but this is only a small part of the whole thing. But both tools do not really, in my view, address working conditions like weather, tide, stream, wave height, etc., which I have mentioned earlier. So, to sum up, the process of learning about from experience is, of course, very welcome, because it helps a lot to avoid mistakes. And standards are basically, of course, tools which help us to know more from experience, provides an external memory, tick list to some extent, brings consistency, quality, and efficiency with us. This is, of course, helpful. But of course, we need to look at creativity, causing inefficiencies, decreasing motivation, limiting flexibility, and also the Chernobyl experience, which means that if you follow a standard plan, which is supposedly correct, but it is actually in the circumstances incorrect, then you may finally end in a disaster even. So in my view, we must be very careful to overemphasize standards. Rather, we must still look at particularities in details, so that we are finally on the safe side, and that also applies, of course, to us in a business environment where DABs finally will have to understand why things have gone wrongly. I thank you warmly, and now hand over the floor to Tobias.
Thanks, Sebastian. So I will switch over to my slides, and I will talk to you a little bit about the practical side as announced. And the problem is you're very early in your project development, normally when you make up yourselves and about your plans, what to do regarding those early contracts. And you deal with a lot of challenges at that time, and then you shall negotiate, for instance, a geophys contract that will later determine a risk share, as Sebastian said, for all later big procurement contracts, like cable installation, like foundation installation, or platform, or the like. And often that gets very little attention in how to identify the respective scope, how to timely plan for it in terms of scheduling. You're desperately looking for those experts that might help you in negotiating an UXO survey contract. So I once experienced with one client where a procurement officer just grabbed me right away from the corridor to help to negotiate an ongoing UXO contract negotiation that was just out of sight in terms of procurement planning, but of course necessary. as you have seen in the presentations of Nick and Sebastian, and this is definitely of help when you think in terms of standardizing those typical contracts that I have enlisted here in the little boxes, because you have so much other problems to care for to get those people on board and push a tender out for those contracts, that at least would be a help if you, as a procurement manager, for instance, in a developer, can just put your hands on a standardized model, at least to adapt that for your very situation. This is something where I would sense practically a very big help from my personal experience of in what situation the project will be at that very time. And you have all those influences, as also Sebastian said. It's not just the soil ground model, for instance, your offshore, you have so many other influences in terms of unregular weather, environmental situation, you deal with, as I said, with UXO. I will detail that a little bit later. Next time the foundation designers on the call, on the phone, and will ask you questions about that. And this is a very tight situation, and I would strongly advocate, therefore, striving for a standardized approach for your portfolio. So identifying scope in detail for what will you need for later to determine a proper risk profile for an offshore project, that this is essential, because only then you can derive what you will need for the composition of your big procurement project as kind of entry points from those early contracts where you get the data from. And as Sebastian also said, the regulatory aspect, for instance, with the BSH, which pushes you, which forces you into some surveys, that's only part of it. And in addition, as Nick also said, you need just also experienced people that pull that off, because there's no general data available. So when you think of UXO as a typical threat, there's no general map out of UXO distribution, for instance, in the North Sea or in the Baltic Sea. There are, of course, surveys from the past, and you can get maps where this is included. But finally, you have to have somebody who operates then later your contractual standard into something worth to be put into a tender that will finally deliver the data that you need to do that risk distribution, as just shown by Sebastian. This will all be included in your overall risk assessment of your development project. And if you don't have this proper team setup, then you, and also in the current auction regime, that's something you will find quite often, that you rather would go for an ITT light kind of concept, but at least core contents that have been described here, that they are absolutely mandatory to be followed and to be included, because they're so detrimental for the big procurement contracts to do that risk allocation later. So typically you cope with insufficient planning in this regard. Everybody is aware that you need geophysical or geotechnical surveys, that's clear, but then also sometimes in terms of cost-benefit ratio, as it was addressed already by Nick, you have to make up yourself what do you want to investigate now and what is to be contracted out there. And of course, this is part of your overall risk determination, as I said, but the but you're easily tempted to save money on those issues because it's a costly thing. That's clear, and it comes from all directions as I've described it. So it costs a lot of money overall. However, you might only find out later on a certain area that penetration tests might have been beneficial and not just desktop study kind of. Yeah? That's something you'll only learn under the execution of the big procurement contracts. And as I said, this first phase of development is often a little bit a nerdy phase in the practical view. And not everybody involved there has that strong reputation, like, for instance, the package manager for the foundation contract, for instance, or even the overall project director. So it might be rather quickly that somebody from kind of the overall management team might try to reduce that budget in terms of the overall situation of the current development projects. And then we see currently projects being cancelled in development due to the cost development and the like. And often those areas of early contracts, they suffer in this just from the practical view. Basically then hitting yourself with that in your project development. So because we saw also in practice that finally vessels have been on idle, because of problems popping up with seabed not properly investigated, and having an installation vessel and maybe also a transportation vessel for monopiles sitting on idle in front of a harbor. At the same time, you can imagine what cost would clicking there in the clock regarding this, because of the enormous day rates of such vessels in those projects. So this is very wisely invested money. And also from that perspective, that normally it will all be much more problematic than in execution that you ever experienced it, because you're operating in a kind of moving environment anyway. So weather will change, hydrological situation of the sea will change, but for instance, also seabed is simply moving. So you it's not like in an onshore situation that you once investigate something and that it might be bad for you, the outcome, but it would stay like this. Offshore, it might not even stay like this. So you have done your survey, and for instance, especially in the North Sea, 6 months later, it might be looking completely different. Sand dunes on the seabed might have traveled, a mile or two, and this is always quite shocking when you see that, and maybe also then the UXO included in there, or some boulder or rock included there traveled with it. And you might find yourself in interesting situations then. So it remains that for the risk sharing for your big procurement contracts resulting from those early contracts, it will be still necessary to kind of distribute the remaining risk resulting from that. And I thought it might be good to take an example from the UXO area, how to do that, or what would be the remaining thing. But what I want to quickly, before I do that, want to show to you is what you normally would have in mind when we talk about it. I will just quickly switch my desktop here. So this is what you would normally have in mind. There was some World War II action, some fighter plane dropping a bomb ending up in water. Maybe this result may be on seabed, but what is a much, much bigger problem that the general person cannot think of is the reality was like that after World War II. Ammunition was just dumped in tons into the sea because nobody knew what to do with it. So you see a vessel here fully packed with unexploded devices, with shells, with bombs, with everything. And this guy, he just dumps it via a ladder into the sea. So this is our situation that we have to investigate, because if that's on the seabed and you drive a monopile through it, that monopile will simply pop out the water, kill everybody around you. This is not what you want to end up with. So basically with dealing with that early UXO issue in terms of early contract to investigate it, you have basically two steps. So the first contract would be you contract out the desktop study or desk study reports, which basically relies on data that are available in terms of earlier studies, historical studies, aerial photography, historic archives, existing finding in projects. And the second step will be UXO survey on certain areas, the core installation areas, before the installation is started, if the study reveals a possible threat that has to be cared for. So our goals there would be in those contracts to basically delimit the geographical areas with potential threat from UXO, but also characterize the nature of the UXO threat and when we think about clearing under such an early contract, to determine what is worth to do or what's not worth to do in terms of that cost benefit ratio, because clearing all that's a very costly thing. Of course, provide then that UXO risk assessment, but also provide a plan for mitigating the UXO risk, because that is what you finally would take, and also the survey result, that is what you would take and put in your employer's requirements in your big procurement contracts, like for a foundation contract or a cable contract, typically. But we have to deal with a lot of problems in this little early contract, so to say. The person's concerned with it. So first, seabed movement. The met-ocean data about it, that might look very quickly very different there on the seabed. We need to define finally, in terms also for the survey, definition of threat size. That would be something for that data set that finally travels into our big procurement contracts. And there you simply identify what could be the UXOs that you could find. It could be a German Telamine 43, for instance, looks like that, which is a quarter of a meter in square, for instance, or a British 250 MC bomb, typical bomb used in from the Royal Air Force in World War II. That's the stuff you find down there. For instance, the Telamine, rather, from that vessel dumping later, because you wonder yourself how an anti-tank mine ends up on the seabed. That's exactly how it was disposed. And then you have to define in that early contract, in an appropriate matter for the risk sharing later in your big procurement contract, the method how to survey. And I put here some examples, for instance, also the 25 centimeter square ratio for a survey cell, but also the technologies how to do that. So quite challenging already. And then you develop a risk scheme, basically, which you transfer, as Sebastian said, later into the big procurement contracts. And that's done basically in the conventional risk management approach, where you define for your risk matrix. Looks like that. Probably everybody knows that, yeah, from standardized risk management approaches. So you have to go back. You have to define consequence class levels, so to say the severity, yeah, of consequences. Activity class, is there a direct interaction or not? Yeah? That's this table. Contamination class, so how's the likelihood, so to say, and then you put it all into that scheme in Matrix. And for everybody who's interested in that, there's a publicly available desk study for Thor offshore wind farm Denmark, and you will find the link in the presentation. That's just publicly available, so you can just follow it up because there's much more in it, of course. And this, the procurement manager dealing with that and the kind of package manager for the early contracts, they have to watch out for all that stuff, that this is finally delivered under those early contracts to be utilized for your later contracts. And this ends up in data like chart as an outline, yeah, from the seabed, because you see here also the shoreline, because the problem continues, of course, on the land-based corridor of your cable contract. For instance, shore bombing or just conventional fighting on the landfall. And this is all put into a strategy how to handle that, what to how to survey in detail, what to clear in what corridors, where's mandatory clearing, to what size, how to survey that. So this is, as you see, a very complicated setup, which is required to be pushed through on the very early basis of your project, with all the limitations on the resource side, on the knowledge side, on the availability of a contractual model, on up-to-dateness of your employer's requirements in this regard. And with very little help, as Sebastian said, from conventional model contracts, because they simply very rarely deal with that offshore situation. Yeah, so if you look at this respective FIDIC clauses, they basically deal with soil, yeah, but they do not deal with the waterline above it, and that's something different. So I hope that gave you a little impression about the practical problems in this regard, and I can only encourage you to invest as much as possible in that early phases. And once you are involved in a dispute, because this is of course the bigger idea here of our meeting, you should always envisage for yourself that situation where those early decisions have been made, and how the results ended up in the respective contracts. And typical contract clause, I just want to read out one because I couldn't put it into the presentation due to the connected NDA, of course. Yeah? But I will read it out for you, that you have an idea how this would end up, for instance, in the platform contract in terms of risk distribution. Basically, the contract requires, as also FIDIC, that the contractor has scrutinized all data that have been made available to him, including, for instance, that UXO study. And then the risk distribution is now done here. In that way, the employer shall perform a seabed scan of the offshore substation site, OSS site, to identify unexplored ordnances within the OSS site, and investigate and clear such unexplored ordnances in each case as specified in employer's requirements, volume 15. And there you find that risk outline where it's determined where the employer would clear and where he would not. And then this is the UXO survey as a definition, and then the clause continues, the result of the UXO survey are provided in annex UXO survey, which has been provided to the contractor prior to entering this contract. The contractor hereby confirms that he accepts the result of the UXO survey and does not have any objections to it. So that's a typical risk distribution where you should scrutinize and raise your voice if you think that clearance on that corridors as described in that survey is not enough, and you negotiate a change there in this regard. So very, very long cycle from that very early thing where you sit there in your office and think, who could I contract for a desktop study, until it travels into that clause months later, when this platform contract typically is prepared or negotiated. Thank you very much.
Thank you all, gentlemen. Before we start questions, just a quick mention, this webinar is recorded and we will cater to all your questions and go beyond the hour. So if you have to go, that's fine. You could access the recording subsequently on the DRBF YouTube channel or in the DRBF library. So now back to the question. I think, Jerry, you have a question for Nick.
Yes, thanks, Georgiana, and good evening all from Dublin. Thanks to Nick and Sebastian and Tobias for three very, very interesting presentations. I started Nick, certainly. Nick, you raised some very important points there to begin with. Could I ask, it's a twofold question really. One, the extent to which desktop surveys at feasibility stage before the detailed surveys are done could be relied on or in any extent useful is the first question. And secondly, the extent to which you mentioned ECI contractors, early contractor involvement, to what extent do you think contractors should be involved in designing a survey program or a survey campaign for ground conditions or otherwise? Thanks, Nick.
Okay, so dealing with the first question, I mean, yes, the desktop study can tell us a lot. They mark out, for example, what the seabed usually consists of. They include some geological data, and they also lay out, where existing cables and areas of unexploded ordnance are. But having said that, I think, as Tobias also alluded to, unexploded ordnance is found in places where it's not marked on the charts. That might be because it's moved in the interim. I mean, bear in mind, we're talking about UXOs or ordnance that was put there, 70 years ago. So that's plenty of time for it to move around, and also to deteriorate in that time as well. So yes, you can start with a desktop, but you certainly can't build an offshore wind farm on that basis. It can only give you a start. And then your second question, sorry, just remind me very briefly.
Yeah, just the extent to which contractor involvement in designing a survey program is
yeah, sure,
useful, Nick. Yeah.
Now, I mean, the point here is that, as I said in the risk allocation, the contractor knows best what to include in the survey. So the contractor, in a way, is the most useful source of knowledge. I mean, there again, as Tobias said, you can also go to experts and so on, but the contractor is the one who's going to have to do the job in the end. So my view is that this is an area where, I mean, there's a lot of talk about partnerships, but this is where a partnership with contractors, where you have a good working relationship with your contractor. He knows that if you start to engage with him, there's a good chance that he's going to be employed. He doesn't know that for certain, but he has a good understanding of that. In that instance, the contractor is going to want to engage and to help you to design your survey. But again, you know, I mean, maybe this is an area where one has to give some funds to the contractor to draw them in to assist in that process. But definitely, however you achieve it, you must involve the contractor.
I agree completely. It's fundamental, really, Nick, to reducing risk, because they're the guys that need the data, and they have the expertise in terms of what's going to be, you know, the challenges are in the ground. So absolutely, you need it there. Sebastian, could I ask, do you think there might be a case to be made for some form of standardized data collection approach for contracts akin to the geotechnical baseline report we find under the Emerald Book with FIDIC? Is there a case to be made for that for offshore wind projects?
Well, I think should have started. Sebastian, you're on mute, and until you unmute, you should address the question to Nick.
Yeah. You're right. Sorry, but I did listen. Yeah, no, not to my mind. There's nothing as we may have regarding the Emerald Book.
Nick, what do you say as member of the task force? Should you consider the GBR?
Well, I mean, almost, you know, I'm an enthusiast in this area, so obviously I'm going to say yes, you definitely should standardize wherever possible. But I think also, you know, one has to consider the alternative points of view, and Sebastian's summary slide at the end, you know, did make the point that sometimes going for an over standardized approach may mean that you're not sufficiently creative and don't seek out all the information that you need.
Thank you.
And on top of the geotech approach under the Emerald Book is actually something which is very special for tunneling, and in a linear concept. And Tobias made that point, which is very important. We do have here much more complexity because we have water and subsoil, which is one of the first preferences, and then even interaction within both. And we're not only talking about progress, and the problem with this geotech approach under the Emerald Book is it's talking about progress per hour, per day, per month in terms of tunneling, boring machines. But it does not tackle the issue how to come to that point. For instance, if you have a vessel coming from Hamburg towards Helgoland, and it takes quite some time, and depending on the weather in between, it takes more or less time. The survival criteria are different, and all this is not you cannot tackle it by such a simple approach like a geotechnical baseline report under an Emerald Book.
Thank you. Before we turn to Tobias for a specific question related to his presentation, a question for all three of you. We talk about early engagement of contractor. What about early engagement of DB at the beginning of the project, and how could a DB benefit the project in terms of site survey? Sebastian, would you go first?
Yeah, well, I do believe that early involvement of DB in general is very much helpful, because when we are able to acquaint ourselves with these matters, then it is much helpful. Though, of course, we have limits in terms of offshore, because if you are offshore on a vessel, you can't see much except probably the wave of the wind. On the other hand, of course, well, the more and better we understand early the risk exposure of the parties, and how comprehensive the data collection is or what is not available, then you have a better view on the complexity of claims and disputes which are likely to come up, and you can better avoid issues by talking to the parties when you do your site visits. And so far, I believe that it may help to identify this potential risk and related claims, and then subsequently avoiding disputes. That's, I think, the biggest potential we have when we are getting involved relatively early.
Thank you. Tobias, what do you think about DB's involvement?
I would even say if there's really a trustful relationship, yeah, with your DAB in that early situation, that might also prevent, without the dispute being there, yeah, by just being consulted. And that's something we also frequently discuss, yeah? How to just consult your adjudicator early in trying to avoid doing mistakes that would lead to a dispute later. And this fits exactly to the situation that I have described, with budgets under pressure, and you might be easily discard all that stuff, and you think, oh, maybe desktop is enough, and then Nick might show up and just tell them refrain from that, because it will end up in a nightmare for you. And I can show you 50% of my disputes dealing with that matter, where you could have closed out an issue there for 500K, and now it turns into a 100 million problem. And I think that could be a very convincing authority in this regard, without the dispute as such being there. Because you would rather not be in dispute with your survey partner or your little survey vessel provider that pulls the sensors there over the seabed. That's not likely that this will happen, although I had such cases too. But rather, I think it's rather the authority coming from, I've seen what happened, to convince the people to follow an appropriate approach in this regard. And this is, I think that would be very beneficial role.
Thank you, Tobias. Nick?
Yeah, I mean, we are talking here principally about contractor. But of course, with offshore wind, we have multiple contractors. And typically there will be probably two contractors who will be concerned with the seabed. One who is installing the foundations, and the other who is installing the cables. And there might be more than two of those. So if only because of the interface issues, about the fact that, you know, what one party finds on the seabed will have an impact on the other contractors. The early engagement of a standing dispute board is a very high return on investment as far as offshore wind is concerned, because of all these multiple issues that we're touching on today.
Thank you, Nick. And now the question for Tobias was, how reliable are cone penetration tests offshore? Do such results tell us really a story?
So when you remember your childhood, working with sand and water, that results often in a mess. If you now want to push something into it, that's a very difficult thing, of course. And the CPT as such has the problem that over the years there were so many methods also how to do it, and the results you get from it, that depends very much on what you contract out, what you ask for, what the very company use as technology in this regard. But there have been, I think, much more also on the technical side, standardization efforts being made also for cone penetration, that it still is, in my perception, of a very important part of the whole data acquisition offshore. But the technology has improved. It has, as I said, has been more standardized. I think API has 4 recommendations for CPT test technologies, basically. And so it still is a vital thing to determine bearing capacity of offshore sand related seabed.
Thank you, Tobias. Now a question for all of you from Barry. New South Wales government has allocated an offshore area between 10 to 25 k's off the coast of Wollongong in New South Wales for future wind farms. The location is 100 kilometers from major power load in Sydney. And already there is a concern that a wind farm located there will disturb the migratory path of whales. Does anybody know of any environment studies regarding the impact of wind farm noise on whales or other sea animals? I know there are some, but I think you're much better prepared than I am here, Nick.
Well, I mean, my first answer is to say that every country that has gone into development of offshore wind farm in a serious way, such as the UK and also the other countries in bounding the North Sea in Europe, have undertaken significant research about a whole variety of topics, not just the impact, impact on mammals, etc. And this has been done through a combination of funding from the government and also joint funding by those organizations who wish to prime this sort of activity and the industry itself. And I'm talking in the UK perspective about the offshore renewable energy catapult. We'll give full details of these at the end of the with the slides. So there's offshore renewable energy catapult. There is the carbon trust, and also many of these studies have been, as I say, primed by Crown Estates, who are the body who own the land on the seabed. So that there are many locations to check for this information, but one would hope that the Australian government will also prime and encourage specific studies that may be more pertinent for the conditions that exist in Australia, and that the developers interested in the Australian market would also participate in that. That the model is well established, it works well, and so it should be copied rather than reinventing the wheel. But there may well be local studies needed, of course.
Thank you, Nick. Sebastian?
Yeah, I can confirm that there have been a lot of work. We have usually in German projects and on these wonderful bubble curtains everywhere, and trying to prevent noise as much as we can. But these studies are enormous, and the problem is that, of course, you have very academic approaches as to that, and that the slightest problem regarding the environment will, of course, also be likely to prevent you from doing it at all. And it's not only whales; it is a lot of wild animal and fauna which is involved in that, and basically in terms of construction in itself, the noise which is linked to that, but also the other environmental impact which is linked to that. But then subsequently, of course, you do have a lot of voices making us aware of killed birds as well, and so on. So it is an endless story, and you will have all balance in between environment protection and the investment and the need to protect the carbon print
You're breaking out.
problems, and that makes it so that there is much available, and we should not reinvent the wheel.
And still, you have the pictures of seals taking a sun bath, yeah, on a secondary scale of foundations offshore. But it turns out also that so bubble curtain is construction, and that is to be assured, you know, that this happens. But I think also in operation, it turns out that this results in a very quiet area of offshore of an offshore site, which becomes a very famous hunting area, yeah, for seals, for whales, because it's simply quiet. There might be a little maintenance vessel circling around there, but for years without a major component change, nothing big is happening there. It's really a quiet zone that turns out to be a kind of biotope. For instance, a famous Belgian developer, they grew mussels there for their food discounter chain that they operate as their main business. They have been invested into offshore wind, and they were they had a mussel farm out there, and this is later the reality. Of course, the construction as such that that poses a certain threat to those species, which have to be managed in terms of scaring them away and using bubble curtain double layer normally, as Sebastian said. But once it's there for 25, 30 years, that becomes a very nice area to live as an offshore species.
Thank you for that. You said 25, 35 years. Think about decommissioning. When you address site conditions and risk, are you also looking at decommissioning? And because I presume it is part of the environmental permitting anyway, and especially in Europe and in the US, but do we deal with decommissioning? And should we have a dispute board up to the very end, up to the decommissioning, to be involved in the whole process?
I don't think you would have a dispute board that you try to run during the operation of the wind farm. Because the number of disputes is relatively modest. It's mainly, for example, to do with cables becoming visible and therefore at risk of snagging and so on. So you wouldn't have the same need for a dispute board during the operational life of an offshore wind farm.
But
I'm not saying you couldn't, but I'm just saying that
I'm thinking
the cost
about
benefit analysis.
Yeah, I'm thinking interaction with the grid. I'm not thinking only from original construction, but as a project as a whole, you could have at some point disputes with the grid operators or
Yes.
sort of thing.
Yes.
So from that point of view.
Yeah. So that's definitely an area where there's a benefit of having a standing dispute board that remains. I mean, in the UK is slightly different in that we have multiple owners of the offshore transmission network. Most countries have a single owner, and that means that therefore that there's a much easier arrangement to put in place to have somebody to a dispute board to monitor that. In terms of decommissioning, that's something that's now beginning to appear on the horizon. But I think we're talking about something that's inherently different than, for example, decommissioning an oil rig, because an existing wind farm, even one that's 20, 30 years old, could have a new lease of life without major change. So, for example, if there was a new generation of turbines built that was much lighter than the turbines that had been installed originally, then one could see that a lot of the infrastructure could be reused. So I would hope that rather than decommissioning, what we'll see with wind farms is actually recommissioning.
Thank you. Tobias, you have a question in the chat?
Yeah, there's another one. Have you seen artificial intelligence being used to assist with better understanding of site conditions? Do you think this will happen soon or still some way off? So thanks for that question. Very interesting. I didn't see it yet, but for instance, prediction of seabed movements, prediction of movements of UXO, that would be a typical application area. I see Nick nodding, for AI to help us there, because that's often just guessing. So you work with that data, you have your survey, 6 months might look different, and you just put into your cable contract, you have to avoid free span on your cable burial. So on the other hand, it must not be buried on that depth that we can't detect it later. Typical risk allocation there could be AI model to assist us there. That could be of big help, I think, and probably somebody is working on that already. Maybe it's even done, but I just haven't seen it.
Thank you so much. So before we close down, if there's no more questions, I would like you to say a couple of final words, perhaps in the order you start talking. Nick, you're mute.
Yeah, I think as has been set out, this is an area where we do need a lot of work. It's crucial to establishing good foundations, if you can excuse the pun, for an offshore wind farm. And yes, I'm obviously enthusiastic about what can be done in relation to standardization. And I guess the crucial message that I would like to leave is early engagement with your contractors.
Thank you, Nick. Sebastian?
Well, I think the comments and statements which we have heard make clear that it is a long way to go. We are just at the beginning, and it is first to follow up next steps, including, of course, such very amazing questions on how we can use intelligent tools to support investigations, for instance. And also, of course, the long-term ideas about the use of DABs is something which we should take in consideration, because the supervision of maintenance and operation and compliance with SLAs and KPIs may require from time to time the use of DABs. Probably not as frequently than you might have that during construction, but my experience is that it is worth to think about long-term contracts, as does FIDIC, by the way, by promoting the DBO and the ODB contract form.
Thank you, Sebastian. Tobias?
Yeah, as I already said, I would strongly advocate for the enough attention for that early phase. And I personally really like the idea, if there is a standing board foreseen, maybe not yet operational, but foreseen for the project, that the developer or the utility project owner already makes use of that setup as we described it, to benefit from that knowledge available, where you only have to deal with later in a dispute where you can't change the facts anymore, where people could simply have avoided that very early for little money. I think that is a very nice idea, to have that senior look on it in a junior project phase.
Thank you, Tobias. So thank you all for joining us today. Thank you again to Tobias, Sebastian, and Nick, and to Jerry for being today with us. And I would like to invite you to our next conference for the 2024, which is going to be our annual Central Eastern European Conference, taking place in Sofia, Bulgaria, between 13th and 15th of March. And a little surprise for those of you who are already members or new members, we are going to have a surprise complimentary webinar on 21st of December of specific interest for the first-time users and practitioners of dispute